of, let me get your title correct, Network and Infrastructure Services at AutoEU, and he'll be presenting full steam ahead to the cloud, private cloud that is, I guess.
Thank you. All right, so needless to say my name now, just skip the first slide. Okay. So just so you know, this is not a technical presentation. We're going to be talking more about from a conceptual where we want to go, right? So, il faudra que je le fasse les deux en même temps. Hein? Okay, that's a bit funny. All right. Okay. So what we're going to be talking is the hype cycles, why we use the cloud, why private cloud, and what we are doing to prepare. There's no question that the cloud is a great way to enhance our IT delivery and productivity. Here at U Ottawa, we use the external cloud for Blackboard already. The student email is now moving to the cloud, and our own ticketing system is in the cloud. We're using ServiceNow. I don't know if anyone is familiar with ServiceNow. Yes. In fact, most of us have been using cloud concepts before we even named it that way, right? If you remember the grid. Also, if you remember those old drawings we did on the network in the early days, when we wanted to represent that area of space that we didn't control, well, we used the cloud. If we go back a little bit further in time, the steam trains. Now, bear with me, I know it has very little to do with today. The first prototype steam locomotive was in the second half of the 1700s. And then the first railroad locomotive was done in the first half of the 1800s, roughly about 100 years of development before we started the full development of locomotives that saw in the 1800 and the 1900. We went from wood burning to coal to nowadays diesel engines, right? So over 200 years of development that changed our nation and the globe. Although the hype of the steam train has definitely passed, or the hype of the train has passed, it's a large part of our economy again today. And even if the steam trains are gone, the diesel trains and the train system is well established. Now, if we go on the, I gotta change this, hype cycles, right? Raise your hand, those who know the Gartner hype cycle. About 1/3. Okay, so for the other ones, let's talk about the Gartner hype cycle itself, right? In the section here, whoops, it's this one. So here we have the trigger, that's the innovator, where people start to think of implementing new stuff. Most of the research is done at this layer, right? That's the early adopters. Then after the first hype, you got the slope of disillusion. This is where we realize the OMGs, like, oh my God, you need this if you want to make it work, and you need that if you want to make it work, and oh, finally that board doesn't really work with that server, and things like that. This is the area where all of that is happening, right? It's also the part where you can innovate and you'll learn at the biggest bang for the buck, because here it's so expensive to do your research, and you have very little other people that are doing the same. When you get in this cycle, everybody that has gone through the most difficult parts are there that they can help, but the innovation has not well been established, so there's a possibility here to learn and get the expertise, right? Then after you have the, after your disillusion, you got the productivity slopes that starts. This is where, if you're not on board by this time, it's a bit too late to try to get into the industry. It's a very good time to get in if you're a user, but not if you want to be a service provider. Now, if we go back to Kamash. It's not working. Good. Okay. Now if we go back to storage, so we're going to be looking at a few Gartner hypes, right? Let's look at storage for now. In the storage, we got iSCSI and all of the SAN management that's well developed. Now, the fact that iSCSI is developed, it doesn't mean that we all have to jump to iSCSI. It's not necessarily appropriate. In fact, at the central services here, we're not using iSCSI much. We're using SAN management, and we have fiber channel over Ethernet. Thin provisioning is the, if you look at thin provisioning that's here, it's well under movement, and it's at maturity. And also any types of storage virtualization. Basically, anyone who hasn't got on the storage virtualization bandwagon, you're late, and you definitely have to start getting into it now, or just forget about it and don't enter that market. The data duplication, if you look at here, is going to be the next hype in data storage. So data deduplication is something that you can start getting into and develop expertise. And if you see here, we got the public cloud storage. I go to the next. Okay, whoop. It's actually here. All right, in server height. Am I here? Yeah, okay. We have grid and hypervisor. If you look at what's developed really well here, grid and hypervisor is very well established, mainframe as well. In some cases, mainframes, some people are moving away, but there are still some nice, interesting technologies that are being developed under the mainframe. On the trend curve, the high performance 8 socket. So anyone telling you that the x86 is not performant enough and you have to go with the RISC platform, well, x86 is really ramping up, and soon you're not going to have to go on RISC anymore to get high performance. Well, it's my own interpretation. We could debate it after the session if you want. And following up the dissolution is all the APC optimization, HPC optimization, VM energy management, and server repurposing. So basically, those are the elements that if you want to be in the game at this point, this is time to start getting into this and learning and getting the expertise. Also, if you look at the slope, what we have here is the offload engines for servers, right? We'll be looking at that a little bit later. If we go on the network technology hypes, we see unified communication. It's really mature now. Here, University of Ottawa, we're late in the game. We haven't invested much in unified communication. We've invested in other areas like our data center. Fiber channel over Ethernet. This is on the dissolution now. So if you want to be learning or getting the expertise, that's the time to get in with the FCOE. Here at U of Ottawa, we're ahead of the game because we were rebuilding our DC, so it was time for us to do the investment, and now it's paying off because we are saving by simplicity. If anyone has had a chance to visit our data center, or if you want to go for a visit, I think there's visits at 5.
I think it's done now.
Done? Yeah. So you could come and see me after the session.
I think we were going to try to schedule some.
Oh,
One more?
perfect.
Okay. So I'm well connected if you want to visit the data center. Okay. Okay, so sorry, go back to presentation. On the curve, what we have is the hosted VDI, right? Now, hosted VDI, interesting question, is hosted by who? Because if you're a service provider, well, yes, you're going to be hosting a virtual desktop. If you look at the way universities are built, there's a lot of it's almost like small enterprises inside the university, right? So central services is a great place to be thinking of hosting virtual desktop for faculties and for services. Now the hype of the cloud. So if I press the right button, yes. Okay. So on the cloud part, cloud advertisement is really mature, right? The infrastructure as a service is also gaining maturity. This is what centrally we're already offering for faculties. If they want to host their servers inside our data center, they can have complete access to their systems. Public cloud storage is here, right? So that's about to reach maturity. Something that just passed the speed bump, interesting enough, is the private cloud. I should be seeing this. Is it here?
Yeah.
Yeah, right there. Okay, yeah. And then, so according to the Gartner hype cycle, The private cloud is entering the peak of inflated expectation. That's what happens just before you can reach your maturity. So you got to be in this game if you want to be mature enough to be on the productivity slope. So where are we? What we've looked at now is storage virtualization. That's a must, right? You got to get onto it, no if or buts, if you want to be offering any types of storage. The network, it's time to strongly consider convergence. Either converge your SAN into FCOE or either use iSCSI or NFS solutions, right? But you've got to get that on your network side. Servers, no more physical. That's pretty much over. Even on a RISC platform, you have virtualization, so there's no reason to do virtual servers anymore, physical server anymore, unless you have a very specific application that we can also debate after this session. Workstations. Workstation, it's time to start thinking about VDI. All of this adds up to points towards a couple scenarios, or three. You can either think of going towards a private cloud, public cloud, or some hybrid version of it, right? So the first cloud. Well, clouds are not new at all, as I mentioned earlier. Converging information into one central location for processing and sharing resources has been around since the time of the mainframe. I was even able to get some little old pictures on Google. Anyone knows Google, that cloud? No, I'm just kidding. Again, does Grid remind you of anything, right? Because Grid, that was the big hype, the late 90s and early 2000. Did anyone go on board with Grid? Confusing? No? Okay, so you did? Actually, the distribution of processing to a large number of smaller computers dates for the second half of the 1900s. Again, interesting, like our second half of their centuries. Now, the business drivers for cloud. Why do we want to go to cloud? Well, it's giving us a competitive advantage. It's the ability to scale the business. Whether we're using a private cloud or a public cloud, it really allows you to grow up and out depending on your business cycles. And one cycle that is common to all universities or education is really the student registration, right? During that peak where you got 2 months of the year where everybody wants to register into classes. I don't know how you deal with the registration. We often have to do segmentations, right? If we had the ability to have clouds that are going throughout the entire province or country, perhaps we could avoid segmentation altogether and say, well, U Ottawa is day so, and then Carleton is day so, and then just separate by universities, which would be much easier for students. Okay, and sorry. It also allows us reduce costs, exponential growth, as I mentioned, and green IT. Most cloud providers recycle the heat, right? So whenever data center nowadays, you're recycling the energy. So if you're using a cloud, you're actually, it's a much better, greener approach. But before we can go there, we had some challenges of our own in our data center. I don't know if you had ever have this issue in your own. Raise your hands who's ever had to deal with this on a Saturday night or something. So you're in for an interesting evening. Try to convince faculties also to bring in their servers when this is what you have to offer, right? That doesn't inspire stability. So before we could go there, we had to address the infrastructure that's needed to offer cloud services, right? So you're going to need a well-constructed data center. What we did is we built a data center that recuperates the heat for the building, so social science. 80% of our energy goes back to the social science building for heating. We're not at capacity now, so physical resources is going to be calling us to increase because it's getting cold in there. No, Our network was converged. That simplifies management and wiring. Our facility was made more secure with the use of biometric, and the entire floor of the data center is restricted area, so not the students don't have access to the floor. You also need sufficient storage, right, for everyone. So what we did is we have 3 V7000 platforms. We're offering over 600 terabyte of virtualized disk space, and we have over provision of about 4 to 1. So our 600 terabyte allows us to actually have 2.4 petabyte as seen by the user, but really we only need to add the disk as we go. And you also need sufficient processing power. So we have 4 VM clusters. One cluster that we call the edge, that's for servers that are facing the internet. We have another cluster called intranet, that's for servers that are in this restricted area. And we have the community cluster, which is where we do P2Vs from any servers that are on campus, that faculties want to join our infrastructure. We do a P2V, we put it in the community cluster that has VLAN in every section of campus, so it makes it seamless, and then we can change the IP address later. We call it the, well, it's like our consolidation cluster. And then we have a VDI cluster. This is our pilot environment. Sorry about that. The VDI cluster is where we're running currently a pilot to have some of our IT staff and a few specialized requirements for administrative that need secured access into some applications in the data center rather than using VPN. We're offering it on the VDI. You also need to offer easy backup. So all of our environment for VMware is backed up on Veeam, which allows very quick recuperation of your data. And all of this applications that are more specialized are with TSM. TSM is robust, and we've been using it for several years now. Now, what it looks like now in our data center, a little bit of a change from before. It's more inspiring when we tell a faculty member or service, yes, we're stable. They tend to believe it more anyways when you see this wiring. We're using a middle of row switching approach for most of our legacy servers, and we're slowly implementing top of rack for our high density frames, such as where we have VMware environment. All of our wiring is pre-terminated, so there's no more hassle of creating wires and testing it and everything. It's all pre-tested, pre-wired, and we just need to do the installation. That's a neat thing. If you want to come visit the data center, I'll show you later how the pre-term works. And we're using all Cat 6A or OM4. So our networking, basically at the data center core, we have the Nexus 7000 for all of the data, and we have the MDS for all of the SAN storage. The Nexus 5K are used to aggregate network and SAN together into FCOE. Now, if we go to the physical infrastructure, we have hot air containment system that gives more efficiency for your cooling. Power and cooling is completely redundant and resilient. Our rack distribution, as I said, is all pre-terminated, and we use complete structured cabling. No more spaghetti wiring allowed. If we look at the data center by the number, we started this endeavor, we had a little less than 500 servers. We're now at 1,100 servers. We offer 24-hour support. We still have a mainframe.
Shiny.
Pardon me?
It is shiny.
It's a shiny mainframe, yes, it's brand new. We're using biometric for security. We have over 2 petabyte of front-end storage because there's all the back-end storage as well. And 80% of the energy is recuperated to keep the building as mentioned. We have 500 kilowatt generator, and we're still using the 3494 tape library from IBM, but those we're going to change, and we're going to put a tape library directly in the vault and a tape library in the data center, meaning no more operations and daily manutention. Daily movement of people with tapes outside of a secured area. All right. So our networks, pre-DC migration, we had the LAN that was completely separated with the SAN. It was a wasted of resources, complexity in management, redundancy without more resiliency, because you need to have twice the environment. And then if you want to have resiliency, you need to have twice the environment. So really not cost effective and not flexible. If we look at our network now, it's converged at the access and server layer. We still have a core and a SAN core. The next iteration, we're looking at replacing the SAN core and putting it all in the V7000, where because the 5000 series allows us for convergence. On the virtualization, currently we're using our hypervisor is Vsphere. I won't go into details of virtualization. That's not what the session is meant. But we have 4 different clusters in building blocks. That's how we implemented it. We have our Vsphere blocks. That's the edge and intranet cluster I was talking to you about. Our vCloud block. This is where we're actually starting to explore on the vCloud environment. It's relatively new. And this is where we're going to be putting all of our community cluster and let our IT colleagues from faculties full control of their required services. And then there's the VDI block that we're implementing for faculties, and we have a pilot that's running for students with Faculty of Science. If we go into disk storage, basically we have a tiered infrastructure for storage. The first 1% is the most expensive storage. We're using DPS 8800 with SVC, and it's basically just for our SIS and our ERP. Only 1% of our storage is there. The second level is the mainly IBM storage. High performance, we're using V7000s there. The DS 5100, 5300, I don't know if you're familiar, but it's the precursor to the Storewise. And at this layer, we have about 40% of our storage. We're using it for VMware, Exchange, all of our file servers. The last is for backup only. It used to be primarily Promise appliances because backup by definition is not your most business critical. However, we just purchased a IBM DCS 3700, and we're going to be putting all of our Veeam infrastructure in there because it's going to be a replication. And if we need to pop up a server, we need to have the performance behind it and the reliability as well. And we're still using tape drives and tapes for the archiving. If we go into storage virtualization, just a quick note. For those who are not familiar with storage thin provisioning, basically what it allows you to do is that you can provision 30 terabyte of storage using only 20 terabyte of disk space. And if there's actually only 1.8 terabyte used, you know that you still have 18 to go, and you don't have to provision new disk space until you're actually using it, right? It's not so much that you're saving on space, which is, but it makes management much lighter. You don't need to provision the disk space just based on what's available. You can provision disk space for servers exactly on what you think the server is going to be using, and then you don't have to worry about it anymore. Don't have to go back in Windows and expand your disk and stuff. So what are we doing for DC security? We have 3 approaches for the data center security. The first is policy-based security, not allowing anyone that doesn't really have to have access. So only support staff and critical vendors. For instance, we have a contract with IBM, so IBM does have the tech with IBM has access to the data center. The second aspect is physical security. Well, we're using HID cards and biometrics with security cameras as well. The third is firewall, antivirus, and IPS and IDS. I don't know if anyone knows Pete Hickey. So those who are familiar with Pete, he's our IDS and IPS guy. We're going to have to replace him with hardware because he's going on retirement now. Data center as a service. So that's really what we're offering faculties, right? About 40% of the servers on campus are outside the data center. The idea is that now with the corporate data center that we offer data center as a service, and faculties can come and put their servers inside and have access to their servers. Most of the application that we have there is the SIS, ERP, UOZone, and file services. And then infrastructure as a service. Basically, we offer it, what we're using is the VMware platform, as mentioned earlier, and we make it available to faculties rather than buying your server and then coming to the data center and racking it. Just ask us for a VM, and we offer them for free in most cases. It makes the data center as a service almost obsolete, but it's still available. For instance, we have protection services that have a special project to replace all their cameras with IP cameras, so they need to film everything and make sure it's recorded, and for security purposes, it's better that we don't access that storage. So they're using us as data center as a service. In the backup services, basically, what we did is we oriented towards TSM and Veeam, as I explained earlier. We have 4 different platforms actually. We have NetBackup, Commvault, TSM, and Veeam. We're migrating away from NetBackup and Commvault for management simplicity. So basically, TSM and Veeam are going to be our 2 only agents in the future. So this is, remember when I talked about a Vsphere building block? That's the concept behind the Vsphere building block. That we have some hosts, we create a cluster, and then we offer the cluster with this is the edge I mentioned about the community, the restricted. And as we move up towards vCloud, the community cluster is going to go in the vCloud environment, and then we're going to let faculties self-provision. This is the how we provide storage pools. We have the enterprise, that's where we have our ERP, our SIS system. Student, this is where we provide general student services. It's not students that have access to that storage, it's storage meant to all the platforms that are delivering services to the students, like Eurozone or the portal. Then academic, this is what we offer for faculties, labs, researchers is another block, sorry. So faculties and labs, we offer them storage on the academic pool. And then we also have our own infrastructure pools for file shares and exchange and all the other services. Data protection, we're simplifying data protection. Anything that's virtual is going on Veeam, backup and replication at the same time. Everything that's physical is going on TSM. TSM, we're still going to use some Promise appliances. They're low cost, and the idea is that everything gets backed up on the Promise overnight, and then during the day it all gets back copied on tape library. So we're not concerned as much if something should be complicated with the Promise. It's a sufficiently reliable platform, and it allows us to lower the total cost of ownership. So what's next? Well, we have VDI exploration. We have two pilots running for VDI. The first pilot, as I mentioned earlier, is the IT staff and the administrative staff that we have special needs. The cluster is there, it's in production, we're not touching anymore. We also have another cluster that we're just fiddling with, playing with, testing some offload engines. The idea behind the offload engine is that we think we're gonna be able to offer a better user experience. We've made some tests ourselves. If you're using an offload engine, you can watch a video. We should have ran a simulation of that. We could probably start one, but then I'd be scared to test something live that I haven't tested. But anyways, so we run some VDI tests with graphic offloading. You can watch full HD seamlessly. As compared to not having the offload engine, you can see that there's a little there are some jitter. Is it an expression? Jitter in the play. And the second initiatives, this is where the offload engine is going to come handy. We're working with faculty of science actually. We're running a pilot right now where we're offering their labs already. So half of their labs is on their own infrastructure, and the other half is on our central infrastructure. The idea behind that is that we provide the minimum infrastructure. Any faculty that want to join in just need to bring in the extra load that they would have with their labs, and we provide all the licenses. So it makes using central services a good incentive, because they're going to save. They save on building the initial infrastructure, save on time, And also the licenses, if they're not using the lab 100% of the time, they don't need to purchase 100% of the licenses because we have the licenses that are going to be used sporadically on campus. Any questions?
There's one on the live queue.
Oh. So Wade, could you read me the?
Sure. What is your charging model for VM storage?
Well, actually, we're not charging for VM as long as they're under 500 gig of disk space for faculty for their servers. But is it okay?
We need to update.
You don't get that with VDI.
Yeah, we should run it in a virtual machine.
So we're providing servers for faculties. We don't charge unless, as long as they're under 500 gig of storage. If it goes over 500 gig, we don't have a real model. We look at what's the last price that we paid for our own storage. If you look at it with the virtualization and everything, it comes to about $1,000 a terabyte. So terabyte, yeah, about $1,000 a terabyte. So for heavy users, we're just going to charge whatever we paid last time. The idea is that we're making it as affordable as possible. And if you don't need a terabyte and you can use just 500 gig, well, just come in and bring your servers. Any other questions?
What drove you to create multiple clusters rather than just creating one? Because in particular, the one that's internal versus the community.
Part of it's security, because in the network infrastructure, if you're creating a cluster that has access to all the VLANs, you're actually putting yourself at risk somehow. And coming from a network background, myself, I was a little bit tighter on saying no, we're not putting those VLANs together. We're not aggregating the restricted VLANs with the DMZ VLANs. So we create with no DMZ is okay. The restricted VLANs with the internet VLANs, right? I know that the folks that are more inclined on virtualization, they feel that no, the switching system, there's no problem at all, but there's no problem until something actually happens. So we decided to remain segregated.
Also, we needed a split point because to have a too big of a cluster, so we wanted to have a more of a manageable size cluster, so that the more easier way to split the clusters were to define one that will be hosting edge for the public side and the intranet. We had decided to do one. And also, if we compare the type of applications that we're running on the edge are more memory hungry compared to the applications running on the intranet restricted are more CPU hungry. So we have a difference in between even the clusters itself, so the way we provision it.
Thank you, Pascal.
You have another block that's for researchers, you said?
Yes.
How is it different or used differently?
Well, the block for researchers is actually in another data center because we have a facility that was built a few years ago in the Marion building. That was a precursor to building a corporate data center. There's no tangible reasons why you should keep research separate other than if the researcher is using 100% of the CPU 100% of the time. That happens a lot in research, which doesn't happen in the corporate world. We see some of our researchers that are keeping their CPU load at 99% for 3 months at a time, right? So there wouldn't be gain in the shareability in that aspect.
Do you do database hosting?
No, we do only server hosting, but they can host their database on the.
From a licensing
yeah.
perspective, you haven't centralized it.
We haven't, no. Database licensing is one of the issues or concerns that we have because databases are popping all over, and most people, when they pop a database, they buy their own license. The thing is, you're not necessarily taking advantage of the licensing model that allows you to share the database, right?
What mechanism are you using to allow people to request new VMs, and what's your turnaround time?
Our turnaround, I'd say, well, I'd revert to, it's Betsy, Estar?
No.
What, Estar, what's our turnaround time for VM?
You want a VM, you call the help desk at 555 and you got it the next day. Or the same day, sometimes it's an emergency, sometimes you have to clone it right away, depending. But then you have to talk about the networking, like what's gonna be hosted, what's gonna be on the VM, so we know where to put it. Is it student info or is it just a web?
So the next day, once we know what you want, but it's more of a week before we turn around a VM because we want to have discussions. The idea to go towards the cloud, vCloud, is that, well, and we're exploring on the cloud, right? So we haven't really implemented, we have a small implementation that we're doing on our own. The idea is that we want to have self-provision. We don't want to be discussing the requirements for faculty. We just want to have the environment that's there and then just add some capacity when it's required.
So we do also on the community side, when we also have like a sandbox approach where we have resource pools, like we configure resource pools for specific faculties, and that faculty has his resource pool, so he doesn't even need to ask for a new virtual machine. He creates his machines as he wants, and that's one of the first steps where we took to get to the vCloud approach.
We have two faculties that are, well, actually one faculty and one service that are actually running that way. Now we gave them access to the cluster and storage pool, and they can create their own servers.
So how many faculties have fully subscribed to the service and are any fully being serviced by you?
Okay. So fully, there's one faculty that is actually fully dependent of our services. There's 10 faculties at the university. Most faculties actually do have servers in our infrastructure, but they still have their own infrastructure. They're more on a hybrid cloud, their own in ours. And eventually the idea is that slowly, as our infrastructure becomes more robust and more available, they're going to be moving towards our infrastructure. Right.
Do you have firewalls at the VM level?
Can you repeat?
Do you have firewalls at the VM level, between VM to one VM to another VM?
Yes.
Yes. So on the VM security layer, we're using Trend Micro. It's agentless. So that for us, that was one of the key requirements. We don't want to be managing firewall or antivirus on each server anymore. You can imagine 1,000 server. Even if you have some management platforms, the easiest is let's just manage the one on the host and it'll take care of the rest. There's a little caveat there. Sometimes if you have a file that Trend Micro doesn't know is safe, it could interpret it as a threat, and it just deletes the file. You just don't see it. And it's actually funny to see because you drag and drop your file and then you look on the server, it's not there anymore. But so that's the little caveat of running an agentless.
So is this firewall installed on each server or on the?
Only on the host.
Yeah.
Right.
So basically, on the production side, we do leverage ASA modules and FWSMs. So we have different VLANs, and those virtual machines are a part of those different VLANs, and we have physical firewalls that separate them. Our plan when we get to vCloud, we want to leverage either Trend Micro to use the virtual firewalls and basically use vShield, or leverage vShield itself in VMware to recreate the same security that we have on the physical side with the physical firewalls, recreate the same sense of security at the virtual side with the vShield.
So any new server that we create, the virtual servers, we don't longer need to put or activate the firewall of the server itself. The IT that will be using it sometimes will still activate it. It's not a requirement that they don't. The antivirus, though, we don't want to be running on the guest because it creates more CPU usage at the host level. But the old legacy servers that were transferred still have their own antivirus and firewall, and we have a process of going back to all those servers and taking off the old antivirus. Any other questions?
Do you have a library of templates that you make available, or are the VMs?
So,
No OS installed.
so no, yes, we have templates, and we work with, CCS in itself is divided, right? We have enterprise services, student services, and we have the infrastructure. Each service can create their own templates of servers that they need to deploy. And as soon as they created the template, we make the template available. And we can do the same thing for faculties as well.
Are they responsible for licensing OS?
Oh, for the OS, we use Data Center from Microsoft. So the entire virtual infrastructure no longer needs the licensing for the OS, but you still have to consider databases, right? So if you're providing your own server, you have to make sure so if you install Microsoft SQL, you're gonna have to install your license. However, we also have some of our hosts that are covered with the Microsoft SQL licenses. If people tell us that this is what they're going to do, we're going to direct them towards those hosts to take advantage.
Also on the Linux side, we are using SUSE for VMware. So on that side, we are also licensed because of VMware. So we're pushing people to use SUSE on the Linux side.
Are you using any external cloud services or thinking about it?
We are using some cloud services. We haven't done some convergence of cloud services, but we're not using server cloud services, right? What we're using is the software as a service for Blackboard. We're using it also for ServiceNow and Google for our student mail. Any other question?
Okay, let's thank the speaker.
Thank you.